Good morning, Prep 2. Today we are going to start our first session of our science course. But before we start, we have to remember some important information that we studied before in Prep 1. We have to remember what is meant by an atom and the atomic structure. We said that any atom is composed of two main parts, which are nucleus found in the center of the atom and the electrons revolving around the nucleus in energy levels. So any nucleus is found in the center and it's composed of protons and neutrons. Protons, they have positive charge and they found in the center. And the neutrons, they have neutral charges. They have plus and negative on the same particle. Okay? Around the nucleus, electrons are revolving, which carry negative charges. So I have a nucleus and electrons revolving around the nucleus. Okay? Now we are going to talk about atomic number, as we remember that the atomic number is the number of positive protons found in the nucleus or the number of negative electrons revolving around the nucleus. Okay? In this case, the atomic number is 5. Why? Because I have 5 positive protons. And the atomic weight is 10. Why? Because the atomic weight is the sum of protons and neutrons as well. So I have 5 positive protons, 5 neutral neutrons, and so the atomic weight is 10. So for an element like this, it's the atomic structure of boron, and it's an element. Its atomic number is 5, and its atomic weight is 10. Before we start, we have to ask ourselves one question, which is, why do we have to arrange anything in our life? Why do we have to arrange our clothes? Why do we have to arrange anything? Simply, as you see, we have a mixed colored balls. To count each color alone, we will take time to search and separate them and then count. But if we arranged them and we grouped each color together, each colored balls together in a group, we can count them more easily. 3 times 9, 27. 3 times 5, 15, and so on. Okay? After that, we are going to start our lesson, which talks about attempts of elements classification. And attempts means the trials, how the scientists try to arrange the elements, to classify them in one table, So the first question is, give reason. Attempts of scientists to arrange the elements. Why scientists try to arrange the elements? Number 1, to be easily studied, as we said that any arranged thing can be studied easily. Number 2, to find relation between elements and their physical and chemical properties. We have 3 periodic tables. The first one is Mendeleev's periodic table, made by a scientist called Mendeleev. The second one is Moseley's periodic table, made by an English scientist called Moseley. The third one is the modern periodic table, and it's not made by one scientist but a group of scientists together. Okay? So we have 3 periodic tables that we are going to study in our lesson. First one is Mendeleev's periodic table, the periodic table made by Mendeleev. It's called the first real periodic table. Why? It's called the first real periodic table because before Mendeleev, many scientists tried to arrange the elements. But the best try in this time was Mendeleev's periodic table. So it's called the first real periodic table. Number 2, he put his table in his book, Principles of Chemistry, just an information. Number 3, only 67 elements were discovered. When I ask you how many elements are found now, we have 118 elements and maybe more, okay? But at the time of Mendeleev, only 67 elements were discovered. So he was working on arranging only 67 elements. How? First thing, he brought 67 cards, card for each element. And he noted, number 1, the name of the element. Number 2, element's atomic weight. And as we said before, that the atomic weight is the sum of protons and the neutrons. So Mendeleev used the atomic weight to arrange the elements, not the atomic number. Number 3, he wrote the important properties of elements. Some important properties like what? This element is shiny. This one is not shiny. Metal, non-metal, okay? Color, not colored. dissolve in water, doesn't dissolve in water. All these are called the properties of elements. For example, he wrote the symbol and he wrote only the atomic weight, not the atomic number. So when I ask you, Mendeleev arranges the elements according to what? According to their atomic weight. After that, he started to collect the chords that have the same properties, the elements that have similar properties in one vertical column, and this column is later known as group. Okay, so when I ask you, Mendeleev arranges the element with the same properties in vertical columns that are known later as groups. After that, he divided each group into two subgroups. He divided each group of elements into two subgroups, as each group of elements inside this group that are more similar are found in one subgroup. Okay, this is a sample for Mendeleev's periodic table. For example, okay, as we see that any table is composed of two main parts, which are rows and columns. First row, second row, third row, fourth row. Okay, first column, second column, etc. We found that elements are arranged in an ascending order according to their atomic weights. When Mendeleev arranged the elements according to the properties, elements with the same color, with the same color, with the same color in vertical columns, he found that elements are arranged in an ascending order from the smaller in the atomic weight to the greater one. 5, 7, 8, and 10, ascending order, according to their atomic weights in the same row from left to right. And we said that row is called period letter, like the column is called the group, but letter, not now. Number 2, these rows were later known as periods. So period 1, period 2, period 3, and period 4. Group 1, group 2, group 3, and group 4. Number 3, properties of elements are repeated by the beginning of each new period. How come? The first period, the colors are found like this. The second period, the colors are repeated. So as we start a new period, the colors are repeated like the previous period. Okay? After that, we are going to talk about the advantages of Mendeleev's periodic table, the right things that Mendeleev did. Number 1, he left the gaps in his table. He left gaps. What's meant by gaps? Gaps mean empty spaces. Place like this that contain no element. No element is found in this place. Okay? Why? Because he predicted that in the future, we are going to discover an element that fit in this place. So when I ask you, give reason, Mendeleev left the gaps in his periodic table. Because he predicted the discovery of new elements that fit in these gaps. Number 2, he corrected some wrongly estimated atomic weights. As we said before, that Mendeleev used the atomic weight of an atom or of an element as an indicator to arrange the elements. Okay? While he was working, he found that some elements are wrongly estimated. For example, element X has atomic weight 5. While Mendeleev was working, he found that X has atomic weight 7. So he corrected the atomic weight with 7 instead of 5. Before we talk about the disadvantages of Mendeleev, we have to talk about isotopes. What is meant by isotopes? Isotopes are forms of the same element which have the same atomic number. They have the same atomic number and different atomic weights. Again, forms of the same element which have the same atomic number but different atomic weights. Like this, all these elements are hydrogen. They are all hydrogen. Okay, what's the difference between hydrogen, hydrogen, and hydrogen? This one has 1 proton, so it has atomic number equal 1. And the atomic weight equal 1, so there is no neutrons. Neutrons equal 0. This one has atomic number equal 1. And the atomic weight equal 2. 1 proton and 1 neutron. This one has atomic number equal 1. But the atomic weight equal 3. 1 proton and 2 neutrons. What is the difference? They have the same atomic number but different atomic weights. So these forms are called isotopes of hydrogen element. They are all hydrogen but with different forms. Like us, we are all humans, but we are different from each other. Okay? Disadvantages of Mendeleev's periodic table. Number one, the first mistake. He had to make a disturbance, and disturbance means disarrangement. It's not arranged right, okay? He had to make a disturbance in the ascending order of atomic weights. For example, when we look at period number 2 or row number 2, we find that 11, 15, no problem. When we look at row number 3, we find that 20 and 18, there is no ascending order. There is no ascending order. So he made a disturbance in the ascending order of an element. Why? Why would he destroy his ascending order? To put them in groups that suit their properties. For example, 18 is found at any place, but he took it from this place and put it right here. Why? Because this element that has the atomic weight equal 18 has the same properties of this group. So he took it from its place and put it in this group. Why? Because this element has the same properties of this group. So simply when I ask you, Mendeleev made a disturbance, give reason to put the elements in groups that suit their properties. Second mistake, he would have dealt with the isotopes of one element as different elements. Why would Mendeleev recognize the isotopes of the same element, the different forms I mean, as different elements? Let's take a look back on this. For me, this is hydrogen, and this is hydrogen. Why? Because they have the same atomic number. But as we said, Mendeleev used the atomic weight as an indicator. So when Mendeleev look at this, he finds 1, 2, 3. So Mendeleev recognized these 3 elements as 3 different elements. Okay? And it's a mistake because they are the same element but different forms. So when I ask you, give reason, Mendeleev would have dealt with isotopes as a different elements simply because isotopes or they have different atomic weights. So they are considered as different elements for Mendeleev. Number 3, he put more than one element in the same cell. This is called a cell that contains only one element. But Mendeleev had to put more than one element in the same cell. Why? Because these elements are similar in their properties, very similar in their properties, so he put them in the same cell, and this is a mistake. Note that after Mendeleev, another scientist came, which is called Rutherford. What did Rutherford do? He discovers that the nucleus, which is red right here, contains positive protons. So Rutherford discovered the atomic number, and that's why Mendeleev didn't use the atomic number. It was not yet discovered. Okay? So after Mendeleev, a scientist called Rutherford, he came and he discovered that any nucleus contains number of positive protons that we call the atomic number of an element. Mouseley's periodic table. Number 1. Moseley said that elements must be arranged according to their atomic number, not their atomic weight. After studying the properties of X-rays, he used the X-rays to identify the atomic number of an element. After that, after finding the atomic number of an element, he arranged the elements according to their atomic number, not their atomic weights. When I ask you simply, mention the scientific principle of Moseley's periodic table, elements are arranged according to their atomic numbers. Mention the scientific base of Mendeleev's periodic table, elements are arranged according to their atomic weights, not their atomic numbers. Number 2, he added a zero group that contains inert gases. Number 3, he left a place below the table for lanthanides and actinides that we are going to talk about later. Bohr, another scientist came after Rutherford called Bohr. What did Bohr do? He discovered the main energy levels. As we said before, that any atom is composed of a nucleus in the center and the energy levels in which the electrons rotate around the nucleus. Who discovered the energy levels which are K, L, M, N, O, P, Q? Bohr. How many main energy levels? 7. So Bohr discovers that here is the nucleus. There are 7 energy levels in which the electrons are rotating around the nucleus. Number 1, K. Number 2, L. Number 3, M. N, O, P, and Q. 7 main energy levels. And when I say main energy level, this means that there are other type of levels. After that, other scientists had discovered the energy sub-levels, which are 4 types: S, P, D, and F. Okay? Each main energy level, like K or L or M, is composed of smaller sub-levels, S or P or D or F, or more than one. Okay? So each main energy level contains one energy sub-level or more. For example, K is the main energy level. It consists of only S. There is no P or D or F. L is the second energy level. It consists of 2 energy sub-levels, S and P. Another example, M is the third energy level. It consists of 3 energy sub-levels, S, P, D. Okay? The third periodic table is the modern periodic table. As we used to say the scientific principle of Mendeleev's periodic table, Moseley's periodic table, we have a scientific principle or rules. According to these rules, we arrange the elements. The rules or the scientific principle of the modern periodic table is called, or is number 1, their atomic numbers. Elements must be arranged according to their atomic numbers. Number 2, the way of filling energy sublevels that we talked about before, S, P, and D, and F. So we have 2 rules. Number 1, the atomic numbers of elements, like Moseley's periodic table. Number 2, the way of filling energy sublevels. When I ask you, simply mention the scientific or the fundamental scientific principles of each periodic table. Moseley's periodic table, elements must be arranged according to their atomic number. Mendeleev's periodic table, elements must be arranged according to their atomic weights. The modern periodic table, elements must be arranged according to their atomic numbers and the way of filling energy sub-levels. This is the modern periodic table, okay? Let's take a look on the modern periodic table. Number 1, we said that each row will be called period. So this is period number 1, period number 2, period number 3, 4, 5, 6, and 7. How many periods are found in the modern periodic table? 7 horizontal periods, okay? What about the groups or the columns that we are calling now groups? Number 1, group 1A, 2A, 3, 4, 5, 6, 7, 8, 9, 10, 18 vertical groups. Description of the modern periodic table, the components of the modern periodic table. Number 1, it has 118 elements, the number of elements that we found till yet. These elements are divided into natural elements that are found in nature, which are called or have the number 92, and artificial elements made by us, 26 artificial elements. There are space horizontal periods and space vertical groups, 7 horizontal periods and 18 vertical groups found in the modern periodic table. Elements of the same group, they have the same properties. Give reason. Because they have the same number of electrons in the outermost energy level, as we are going to say later. We have 4 blocks in the modern periodic table. We have 4 blocks. What's meant by block? Back to the table. We have this part is called S block. We have this part which is called D block. And we have the rest P block. And this part is called F block. So we have 4 blocks which are S block, P block, D block, and F block. S block, 2 groups found at the left side. P block, 6 groups found at the right side. 1, 2, 3, 4, 5, 6. D block is found in the middle and it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 groups. 2, 10, and 6, 18 vertical groups. F block, it's found below the periodic table. As we said, that mostly left space for lanthanides and actinides. Okay? Let's talk about each block. S block, found at the right side of the periodic table. Sorry, at the left side. Number 2 consists of 2 groups, only 2 groups. The first one is called 1A and the second one is called 2A. And these numbers are called old numbers. The new numbers are 1, 2. Okay? All groups are symbolized with letter A. All groups of S block are symbolized with letter A. P block, it's found at the right side. How many groups? Only 6 groups. Located at the right side of the periodic table, consists of 6 groups, which are 3A to the 0 group. 3A, 4A, 5A, 6A, 7A, and the last one is called 0 group that contains noble gases. All groups are symbolized with letter A, 3A, 4A, 5A, 6A, 7A, except the last group, it's called 0 group. D block. D block is found in the middle of the modern periodic table. Consists of 10 groups. Focus. 10 groups, starting with 3B, 4B, 5B, 6B, 7B, and we have 3 groups together are called the group number 8. Then 1B and 2B. Symbolized with the letter B, not A like S and P blocks. These groups are symbolized with the letter B except group 8 that contains how many vertical columns? 1, 2, and 3 vertical columns. Number 4, these elements are known as transition elements. When I ask you, elements of D block are called transition elements. And they start to appear from the period number 4. What's meant by they start to appear from period number 4? The first period, there is no element of the D block. The second period, there is no element of D block. The third period, there is no element. The fourth period, here is the first element of D block. So, D block elements start to appear from period number 4. F block, the last block. Number 1, it's located below the periodic table. It's located below the periodic table. It's found here. Okay. Number 2, it consists of, there is no groups, 2 horizontal series. The first one and the second one, lanthanides and actinides. The first series of F block is called lanthanides and the second one is called actinides. And here is the end of our first part of our first session. I hope you understood it.